Students, in our today's class, I'll explain about phosphonitrilic compounds, or these are also called as phosphazenes. So actually phosphonitrilic name itself indicates that these compounds consist of phosphorus and nitrogen. Okay, so let us see the definition. These are the cyclic or acyclic polymers of nitrogen and phosphorus. Cyclic means they'll form a ring-like structure. Acyclic means we can observe a linear or any other chain formation. So they are cyclic or acyclic polymers. Polymers means many units combine together to form a long chain. So these are cyclic or acyclic polymers of nitrogen and phosphorus. Okay, so if we observe group 15 elements, already we have discussed the general electronic configuration and their properties of group 15. If you observe nitrogen and phosphorus having very small size, the size increases from top to bottom. So we can say that nitrogen is the smallest element in this group. So nitrogen, phosphorus, because of their small size, they have a tendency to form a long chain compounds, that is called catenation. Catenation is nothing but tendency of a same element to form a long chain compounds. Like you observe diamond, graphite, that is carbon formation. Here you can say nitrogen, phosphorus together undergoes catenation to form a phosphazenes. Okay, so and they have a general formula PnX2 whole N, where X can be any halogen, fluorine, chlorine, bromine, or methyl group or aryl group, C6H5 phenyl, okay, SCN, thiocyanide group, we can say methoxy group also can be involved. So X can be any of these groups. Okay, so N is a value which is ranges from 3 to 7. We can keep 3 to 7 values for this N. And these compounds consist of P double bond N. P double bond N will be there in this particular compound. So you can observe this unit N double bond P X2. X can be any halogen or aryl or alkyl groups. Okay, so here this unit will be continuously repeated in this particular polymers. Okay, so let us see phosphonitrilic chloride. So actually I am substituting X place with chlorine, because in our syllabus we are having phosphonitrilic chlorides only. Okay, so if we keep chlorine, and I'm giving the number for this N from 3 to 7. So let us observe the compounds now. PnCl2 thrice, whole thrice. So we'll get P3N3Cl6, P3N3Cl6. This is called as triphosphonitrilic chloride. Triphosphonitrilic chloride. This is also called as triphosphazene. Okay, so if I keep 4 in the place of N, I will get this as a P4N4Cl8. P4N4Cl8. So then we'll get this as a tetraphosphonitrilic chloride. The name of the compound is tetraphosphonitrilic chloride, and another name for this is tetraphosphazene. Okay, let us see the next one. If I keep 5 in this place, in the place of N, then I'll get PnCl2 whole 5, and we'll get P5N5Cl10. We'll get this as, we'll call this as pentaphosphonitrilic chloride. 5 means we'll say this as penta. Okay, next PnCl2 whole 6. If I keep 6, you'll get P6N6Cl2. This is called as hexaphosphonitrilic chloride. 6 can be hexa. Okay, next PnCl2 whole 7. 7 means hepta. Okay, this can be written in another way, P7N7Cl14. This is called as heptaphosphonitrilic chloride. Okay, so among all these we have triphosphazene and tetraphosphazene in our syllabus. So let us see the preparation, properties and structure of these two phosphazenes. Okay, now let us see the preparation methods of hexachlorocyclotriphosphazene. Okay, that means it is having a chemical formula, that is N3P3Cl6. So you can see the structure clearly. It is having N3P3Cl6 structure. It is having hexagonal ring with 3 N double bond P units. Okay, so that means I told you already it is having N double bond P Cl2 unit. In some cases it is indicated as N double bond P R2 unit. Okay, here we are taking chlorine compound, so N double bond P Cl2. So this particular unit is 3 times repeated. You can clearly, it is repeated 3 times in this particular ring. So it is a triphosphazene. And here you can observe 6 chlorine elements. Okay, 6 chlorine elements. So it is a hexachloro. It is a cyclic ring. So hexachlorocyclotriphosphazene. Okay, so now let us see the preparation methods. First preparation method is aminolysis of PCl5. Aminolysis means reaction of PCl5 or phosphorus pentachloride with ammonia. So you can clearly observe 3 moles of PCl5 is reacting with 3 moles of ammonia and producing PnCl2 whole thrice. Otherwise we can give this formula N3P3Cl6. And along with this you can observe 9 HCl molecules coming out as a byproduct. Okay, this is the first preparation method where ammonia is reacting with PCl5 and producing the hexachlorocyclotriphosphazene. And coming to the second method of preparation, that is here ammonium chloride is reacting with PCl5 in the presence of solvents like dichloroethane or chlorobenzene at 120 to 150 degrees centigrade. Okay, so here you can observe PCl5 and moles of PCl5 is reacting with n moles of NH4Cl in the presence of dichloroethane and producing NPCl2 whole N. So this is our particular phosphazene, and 4N HCl is coming out as a byproduct. So this mechanism, this particular reaction can take place in the following steps. The mechanism of the particular reaction. You can clearly see ammonium chloride is reacting with PCl5. They undergoes condensation to produce NH4PCl6. This is the condensed product which is a highly unstable NH4PCl6. Again undergoes breakage. Okay, it gets decomposed and produce NHPCl3 and 3HCl. Okay, now NHPCl3 X units of NHPCl3 undergoes condensation. That means X unit means many units you can take. It is the monomer. So many monomer units are combining, undergoes condensation. Condensation means they undergo addition reaction with a particular condensation process, and X molecules of NHPCl3 undergoes condensation to produce NPCl2 base X. So X units, this polymer is produced in this particular reaction along with HCl as a byproduct. So here we are getting our phosphazene as a product. That means hexachlorocyclotriphosphazene. You can substitute this N with a 3. Okay. So these are the 2 methods of preparation. Now let us see next method of preparation. Next method is reaction of tetrasulfur tetranitride with thionyl chloride. Okay, here tetrasulfur tetranitride is reacting with thionyl chloride, 6 molecules, in the presence of phosphorus trichloride to produce hexachlorocyclotriphosphazene along with 12 moles of chlorine and 3 moles of oxygen. Okay, so in this reaction you can see thionyl chloride is reacting with sulfur nitride in the presence of phosphorus trichloride and producing the particular phosphazene. Okay, so next method is by direct heating of P5N5X phosphorus pentaphosphorus pentanitride in the presence of Cl2 chlorine at 975 kelvins. Okay, so I'm heating directly this P5N5X in the presence of chlorine at this particular temperature. I am getting this particular phosphazene along with some other byproducts. Okay, here you can substitute X place with the particular 3 or any other number. Here we can produce not only triphosphazene, here tetraphosphazene also can be produced. Okay, substitute this X with the particular 3 number. Then you will get this product. Okay, so these are the preparation methods of hexachlorocyclotriphosphazene. In next class, I'll explain the structure. Okay, thank you so much for watching.